All right. I don't think this is live yet. All right, wonderful. Well, thank you for being here. It's a great pleasure to be here to speak about a topic that I think we all share in common. Thanks for GIDS and the organizers to put this together, a phenomenal event. It's definitely a great pleasure to be here. So I want to talk about, we love developing code, but we also like to be productive. We want to release software. So I want to talk about a few things that I think we share in common. But let's talk about something else that's going on. We all come to conferences like this. We spend times in user groups, read blogs. What do we often come across? We come across latest buzz. So throw some buzzwords at me. What are the things you've been hearing about? What was that? Louder. Docker? Okay. Microservices? What database? Graph database? Cool. Louder. Gosh, I can't hear it all. Okay, what else? All right, what else? AI. How could you not talk about AI, right? Absolutely. So we keep hearing all these. What was that? COBOL. I need 5 people to lift this man out of this room. Thank you, Scott. Microservices, of course, we hear about this all the time. Big data, of course, cloud, right? Everything is on the cloud now. And then we hear about Docker, or is it Moby today? Because they keep changing the name before you could think about it. And of course, functional programming, we keep hearing about it too, right? And then Angular 2, I said, and somebody said, no, it's no longer 2, it's 4. Well, I don't know, because by the time you say the number, it's changed. And then, of course, IoT, we hear about AI, you said that, and algorithms. You know when things have gone mainstream is when television ads use the word algorithm. I'm like, really? And then I heard about machine learning, and somebody corrected me. It's no longer machine learning, I'm told. It's advanced machine learning. I don't have a clue what that means, but that's what it is. So we keep hearing all these buzzwords all the time, and we are trying to catch up with all these things. But what's really going on? What does it really mean? Where are we heading, really? So what it really means is we're really moving towards a high level of abstraction. If you really look at our field, computer programs, software is being used in just about every single aspect of human life. You can't think of anything we do on a normal day in which our activity is not touched by software anymore. It's unbelievable how that's become. And as we are trying to develop these applications to meet these demands, we cannot be writing code at the lowest level anymore. We have to raise the level of abstraction. There are 2 things we do when complexity becomes really hard to work with. The 2 options are, you could take the problem and give it to somebody else to solve it. Well, usually that's us. They're given the problem to us to solve, so we can, in turn, give it to somebody else. And the other is to raise the level of abstraction so we don't have to deal with it at the lower level. So when it comes to this, I think we are at a cusp of a major paradigm shift. I worked in this field for close to about 40 years now, and it's just amazing to grow older in one field like this, where you get to see all the things that have happened in the past. Seeing new ideas and new technologies emerge, and then to see them sunset, and then move on, and then the next wave of things come up. And it's just fascinating to see when you interact with young developers today, when they tell you about things, you look back when you were young and you had to face new challenges. And I remember about maybe 3 times in my career so far when I sat down and I said, gosh, my head hurts. This is very different from the way I've done things. And then over the next 2-3 years, you begin to realize you're doing things very differently than once you did. And then that kind of fades away in the past, and then you meet the next paradigm shift. This happens about every 10 to 15 years, generally speaking. And I think we are at that paradigm shift yet another time now. And honestly, that's exciting to me. Because when you're faced with something new, I know we all feel frustrated, we all feel like challenged, But once we master it, once we conquer that, it feels great. I'm a mountain hiker. I love going up the mountains. And climbing mountains is a lot of hard work. But when you meet that summit, when you're up the top and you can look at everything below you, it is just amazing feeling you have. And that's exactly how I feel with technology as well. Every step climbing through it is a challenge. It's a hard work. But one day you wake up in the morning and like, gosh, I got it. It clicks in your head. And then you feel like you've climbed that summit. And I think we are at the point again, which is beautiful. And the last paradigm shift we had in the 90s was a paradigm shift from structured programming to object-oriented programming. Before that time, most people did structured programming, and all of a sudden, that moment, that tipping point in the 90s was the time when everybody said, all right, OOP is the mainstream, and we started quietly doing it. That was phenomenal to watch that. Well, we went from the structured to object-oriented, but now we have yet another paradigm shift. And then, what is that paradigm shift? Well, you may have thought, I'm going to say functional programming, but it's not. It is actually from imperative to declarative style of programming. When people talk about functional programming, I think they miss out on a very important point. The real power that is influencing us is not functional programming. The real power that's influencing us is declarative programming. And I want to draw the difference and see why that's so important, to strike that difference and see why declarative is really important. So why not functional? Why declarative? Well, the reason really is, in the imperative style of programming, you say what to do, but you also spend a lot of time and effort saying how to do it. In the declarative style of programming, you focus on telling what to do, and you let the underlying libraries figure out how to do it. Well, it turns out the functional style of programming is a subset of declarative style of programming. So when you program in functional style, you are programming in declarative style. But not everything that's declarative is functional. But whatever is functional is also declarative. That's the relationship. So the bigger gain here is the declarative style and not just the functional style alone that we are really reaping the benefit of. So what's the relationship between these? The relationship is that functional style is actually a declarative style plus using the higher order functions that we are used to. But we can see this aspect in several things. In fact, I'm going to go out on a limb and say the way to think declarative is not just about programming. The way to think about declarative is about living. We are changing our ways of life, the way we communicate, the way we interact, the way we behave, the way we work. Everything is moving towards that direction. I'll say why that is in just a few minutes. So given this, imperative really is where you tell how to do, declarative is where you say, what to do. Let's talk about that a little bit. In imperative style, you tell what to do and how to do it. So how does it feel to be able to do this? Let's take a quick example and see what that really means. So let's say for a minute, I have a list of speakers over here. So I need to warm up my fingers here. So I'm going to have a list of speakers. And let's say in this case, my little hands are not functioning yet. So give me a second. So what I want to do here is come up with this wonderful list of speakers we have today, right? What amazing set of names here. Can't even fit that into a screen right now. But I want to know how many of these people have a 6-letter name in their names. So how do I find that? Well, I could start out by, saying, I want to know how many. So we could start by saying, let count is equal to 0. And then, of course, when I'm done with it, I want to print the count. That's my desire, that's my goal. But what do? I start out by saying for, and then I would say I equal to 0, I less than speakers dot length, and I have to pause for a second and ask the question, is it less than or equal to? Do you ever ask that question? Every single day. You write it and you pause and say, is it less than or equal to? And then you walk a few minutes and you stop. Less than or equal to? Do you ever do this? Code like that makes you feel absolutely stupid, right? You go to the restroom and you're thinking, is it less than or equal to? You're having food, your family says, are you okay? Yeah, I'm fine. Are you really okay? Yes, I'm fine. You look very pensive. No, I'm really okay. Just not sure if it's less than or equal to, right? This is unnecessary complexity, isn't it? But that's not done yet. Once you figure that out, then you ask, is it length or size or count? I don't know. Is it length with the parenthesis or without it? There is not enough day in a time in a day, right? Then I plus plus. Is it plus plus I or I plus plus? Look at how cruel this is. Then what do you do to add insult to injury? You say if the speaker's I dot length, and then is it 2 equals or 3 equals? And then of course you say it's going to be 6. Then what do? I say count plus equal to 1, and then you ask it to print that. But if you look at this, this is an example of an imperative style code. You not only tell what to do, but you have to tell exactly how to do it. You are in the business of iteration. You are in the business of saying every single detail. And so the burden is on your shoulders to do this work. Now imagine this. If somebody gives you a bicycle and says, here's a bicycle, use it. Bicycle is great. I love bicycles. I use bicycles. And then they tell you, go to Mumbai with it. You're going to say, are you kidding me? I got to keep bicycling? Yeah, you get started really now because you have to pedal that way, right? Well, you got to scale. You can't scale by using low-level abstraction. You have to at some point say, enough. I can't be coding at this level. I've got to move on. So what do? Let's rethink about it. That is the imperative style of programming we talked about. But we don't want to focus on the details. We want to focus on what, and let the underlying libraries figure out how to actually do it. So let's take a look at declarative in code and see how that's going to look like. We're going to take exactly the problem we saw a minute ago, but in this case, what I'm going to do is rewrite this. So I'm going to say at this point, well, we got the speakers, so I'll go ahead and say this is the speakers list we have, and then I'm going to say, in this case, filter, and given a name, I want to say name.length is equal to, in this, of course, I'm looking for a length of 3, and then I'm going to say dot length on it to find the length of it, and so we can obtain the result of it in a much more elegant manner without having to do all that dancing around. So in this case, we are telling, go ahead and just extract, filter out names that match this criteria, and once you get the value, just tell me the length. You're not in the business of iteration. You're not in the business of looping. You're not interested in managing every single step. You are raising your level of abstraction. You're working with it. This is, of course, in the level of programming we see this, but this is not restricted to programming alone. We can see this quite a bit in every corner we turn. Let's talk about front end for a minute. I want to be able, what do you do when you're trying to develop a rich web application? What are you trying to do when you're trying to develop interactivity? When everything is said and done, you are in the business of manipulating the DOM. And so what are you trying to do? You're taking a DOM element, you're altering it, you're injecting more DOM elements into it, removing stuff, moving things around. But how do you change the DOM elements? Well, the browsers give you an ability to do that. So you can say get element by ID, and then once you get the element, you can say, I want to modify this, and you can call inner HTML. Now what's happening in this case? You're at the most basic low level. You have to know what those methods are. It's not get element by, it's get element by ID, or it could be by tag, and you got to know those details. Depending on what element you're working with, it could be inner HTML, or it could be something else. And you have to know every single detail of every single element you work with, and that becomes a burden, that becomes tedious. You write a lot of code to get things done, it's very error prone. Is there anyone here who enjoys manipulating the DOM directly? Not even Scott. Can you see this? And this is amazing, isn't it? Because the first time you're told to manipulate DOM, you are like excited. You're like, wow, this is cool, I've never done this. And the minute you do it once, you come to a conclusion that manipulating DOM should be given to people in the prison. Nobody in the free world should be forced to do this. It's way too low level. So what do? Hey, we could use a library for doing this. Well, how about using jQuery? We could use something like jQuery. But here's one thing fascinating though. If you look around the past 15 years, I have this theory. The library that's your darling today is the one you're going to hate in 2 years. 6 or 7 years ago, maybe 10 years ago, everyone was using prototype. And one day somebody came to me and said, what's wrong with you using prototype? And suddenly you shouldn't be using that. You got to be using something else. Now people are saying, what's wrong with you using jQuery, right? So everybody wants to keep changing things. But what does jQuery or libraries like that do? Well, you can say $greet. Hey, that's awesome. I don't have to say document.getElement by ID. I can put something more cryptic like a dollar, right? That just please do. Then you say, I'm going to say element.val. Oh, I don't have to call inner HTML. I can use val. But did it really change what we are doing? This is raise the level of abstraction just a little bit, but it's like being on morphine. The pain didn't go away. You just took a tablet to ease the pain. So jQuery is still imperative style of programming. It didn't take away the imperative style. It just covered it up a little bit. That's all. But if you look at something like what Angular does, you would write something like this in this. You would say selector, and you say greet, and you provide a template, and you say what the template value should be. You're not telling how to manipulate the DOM. You're essentially saying, here's the DOM element called greet, here's the content I want to replace, and you're not really doing the work. You're letting the underlying tool do the work for you. Well, what is that? That's declarative style of programming. And so it's not just in the style of writing code, but even in libraries and frameworks and platforms, we are moving towards a declarative style. Because we can be going a greater distance by doing things at a lower level that just is not possible anymore. So how does this really feel? And here's a way I can draw the analogy to what we are doing in almost every aspect of programming and human life as well. Don't get me wrong, I don't care for cars. Seriously, I don't. I mean, I'm good friends with people who love cars. We still have, dinner together. We talk about stuff. It's just that I don't care for cars. When I go to car rental, they would say, what kind of car you want? I would say, one with wheels, please. Because I don't care, really. And they would look at me like, are you serious? You don't care? It's like, seriously, I don't. And so you will never catch me ever drive a stick shift. I think driving a stick shift is the stupidest thing humans can do. Because sitting there and you just have to keep doing this, right? And you have to keep, changing your clutch. I got better things to do. Marginally, I would say I can put up with an auto transmission. Well, the nice thing about auto transmission is there, you put it in drive, you don't have to mess with that anymore, right? Just leave it alone. And you focus on keeping your hands straight. And I'm a guy who usually puts cruise on. We were talking about this morning as well. Cruisers have become smarter as well. They kind of know that there's something in front and they can slow down. I'm like all amazed for this. But if you seriously ask me what I am, I'm neither one of these kind of guy. I am more of this kind of a guy. I like to sit over there in the back seat when somebody drives me around. Seriously. I go into airports. I will take Uber or Lyft or whatever service it is. I'll sit in the back seat, do what I love doing, write code. And the driver does what he likes doing to drive me around the town, right? Or she, whoever it is. And I would like to leave the driving to the driver. The streets are safer, believe me, because of that. I don't have to be driving. And I sit in the back seat and get my work done. The other day I got into the car about 1 a.m. And after a few minutes, the driver said, I want to thank you. I said, why do you want to thank me? He said, because you have a monitor very low. I really like it. And I usually keep my monitor brightness pretty low. I said, yeah, why is that a problem? He said, because sometimes I pick up passengers and I feel like there's a UFO following me, right? So if you're going to be in Uber or Lyft, at least keep the monitor brightness low. The drivers feel the pain. But the point really is, we're now talking about self-driving cars, and I love it. And the beauty is, I like moving around, I like traveling, but I don't like the act of actually having to drive. And that is pretty declarative, right? I get into the airport and I say, take me this place, and I'm done. I don't have to be sitting there and managing the driving. That's, again, declarative if you really think about it. So what is the impact on us doing this? Well, the impact is pretty significant if you think about it. What we do becomes very highly expressive. It is much easier to tell what you want and figure out different ways to do it. Then you have to sit there and keep doing every single step of the way. So what we do becomes very expressive, both in coding, both in libraries and frameworks we use, and also in the society we live in. And things become very concise and fluent, and that is really better. And less we do is better because we can be more productive. When it comes to writing code, the code we don't write has the fewest bugs in it. So I'm all for that as well. And becomes maintainable. Why? Because the things we rely upon are fairly nicely tested, built, and stable, and we can make use of it. And more people use that as well, and that in turn becomes more stable. If you really think about it, right? Relational databases have been used for a good 50 years. There is a reason why they are so solid, because every human ever lived has stamped on it. So it's extremely solid because everyone has beaten it down, and every single bug you can discover has been fixed through the years, right? That's pretty amazing. When a lot of people use it, it becomes really stable as well. And of course, we can deal with rapid change. When your code becomes expressive, you can change it much more easily than when it's verbose, it becomes hard to change it as well. So in a sense, it really comes down to the economics of software development. Well, okay, let's talk about JavaScript for just a few minutes. JavaScript is just amazing in so many, many, many ways. JavaScript is the black swan of computer programming. Black Swan, Taleb wrote a book on black swan. There was a time when humans never saw a black swan. They all saw only white swans. And the first time somebody came across a black swan, what a discovery, right? And black swans are events or things that you never ever imagined. Google is an example of a black swan. It completely changed the world by the time it emerged. And there are several other black swans too, good and bad. But JavaScript, imagine you went to somebody in 1995 and you told them, in 2017, the language you will be excited about is JavaScript. They are told you, you're stupid, go away. But it's unbelievable. If somebody fell into a cave in 2000 and they've just rescued him in 2017, and the guy says, what's the most popular language people are talking about? You say JavaScript, he'll throw me back in the cave, right? It's unbelievable. And how did this become to be a language that everybody talks about? In a way, nobody anticipated this. Well, a quick show of hands, who here uses JavaScript in some form or the other? Absolutely, right? Everyone touches it in some way or the other. But how do you feel working with JavaScript? JavaScript is kind of like this chainsaw. Very powerful. Don't wing it though. Very dangerous, right? If somebody has a chainsaw and it's turned on, and you ask the question, the person turns like, whoa, don't do that, right? That's what you do. You never go talk to a person writing JavaScript. Stay away from them, because you don't know what's going to happen when you bother them, right? It's an extremely dangerous tool, very powerful nevertheless, but very dangerous tool. But the question is, how do you feel when you code with JavaScript? The other day I was writing JavaScript, and I made some change, and suddenly it gave some kind of a weird error. And I'm staring at it. I don't have a clue what failed and where it failed. Do you have that kind of feeling sometimes? Where the code breaks and like, what just happened? So I come with this theory. JavaScript is like an infant. It's cute to play with. But when it fails, you have no clue why it begins to cry. And this is like you call mom and say, Mom, the baby was fine. Now the baby is crying. I don't know. And the mom says, did you pat the baby? I did. Did you put the baby down? I did. Did you feed the baby? I did. Shake? No, don't shake the baby. The point really is, you're trying all kinds of things, and you're just trying to debug this baby. And I think at some point the babies grow up. JavaScript doesn't. And JavaScript is that cute baby. After 20 years, it's still that baby. And when it begins to cry, you're like, what did I do now? Mom, what can I do to this JavaScript? It doesn't work. And that's the way it feels a lot of times. It's a very, very slippery slope. JavaScript is a dynamic type language, but it's also a weakly type language. Weak typing is where at runtime, it has no defense whatsoever. If you really think about it, if you apply logic, this can be really frustrating. For example, I want to ask JavaScript, hey JavaScript, what's 1 times 1? And JavaScript says, why, that's 1. Hey, this is awesome. Things are working the way it's supposed to. You could try 1 times 2, it's 2. Everything is going well. Then you get a little tricky. I want to know what is 1 times 1 when I put them in a string. Now, the result is like, gosh, anybody guesses? Is it 11? Is it something else? And, logically, you may want to get an error, but what does this do? And you run this, it says 1. Like, okay, what about 1.0? It's still 1. Now you're getting curious. What is about 8 times 1? It says man. That's how you make Indian bread using JavaScript, right? And like, how do you reason this? How do you know what the code is going to do? Now, why did it process a string in the first place? Now it doesn't. So the problem with JavaScript is to use the word logic and JavaScript in the same sentence. You never do. And it's a very slippery slope, as you can see. But imagine we are developing so much code with a language that is so powerful and yet so dangerous. But that's one part. What are we doing on the other side? Everyone is agile, isn't it? I mean, have you come across anybody who's not agile, who says, nope, we don't believe in agile development. We are still waterfall, we're very happy. Everybody is agile. I go to my clients, and the first thing they want to tell me is, Venkat, we want to tell you that we are agile. I'm like, I'm so glad we got that out of the way. Now let's talk about what you do, right? Everybody is agile, but what does really agile mean? Well, agile says we should be able to respond to change. Oh, no, not just respond to change. We should be able to respond to change even late in the development cycle. What that means is you are a few weeks before finishing the project, and your folks are coming to you and saying, we just thought of something which is extremely critical. We need to make this change. So could you please make this change for us? And you're going to go to the code, and you're going to make this change, and then you're going to release it, and you're going to expect everything is going to work. How does that feel? So imagine the scenario, right? You go to a developer and say, I want you to fix these bugs, I want to make these enhancements, and I want them all ready by tonight. And so the developer says, yep, I'm done. And then you ask this most dreadful question to the developer. Does it work? And what does the developer say? I hope. There is a technical term for that kind of development. It's called JDD, stands for Jesus-driven development. This is where we put the faith in the Lord. Dear Lord, I worked all night. Please let this work at least in this demo. Don't embarrass me, right? Anyone who has been there before? Yeah, all of us, right? Absolutely, all of us. And it could be JDD. It could be KDD, Krishna-driven development. I mean, pick your Lord. I don't have any preference particularly. But I have this belief, the Lord is way too busy for good things. The Lord should not be bothered by the stupid code I write. In some companies, they don't follow JDD. They follow TDD. That's a different form of TDD than what I want to talk about. There, the company comes to you and says, you will do testing. That's called threat-driven development. That doesn't work either, right? We don't want to go that direction either. So what we really want is an automated feedback loop. In other words, when you have enormous amount of flexibility on your hand, when you are raising the level of abstraction, when you are standing all the way. When I graduated out of school, you didn't have to know a lot. I mean, if you could type, you were hired. You could type? Absolutely. With one finger? You're hired, right? And you could just sit there and keep punching the letters. Because, remember, they came from punch cards. This is a level of improvement already. This dude can use a keyboard, right? But today, you go to interview, do you know this, do you know this? What frameworks? I mean, the level of things you need to know. Unbelievable. When I work with students, and the stuff I have to teach them is just it blows my mind, right? I'm like, my gosh, you got to know all of these before you can present yourselves at work. And when you're standing on the top of that stack, and you're relying on all these abstractions and all these models, all these expressiveness, how much confidence do you have that the things that you do actually works. And if it doesn't, what's going to happen? So there is no point in being productive and fast towards failure that it becomes unpredictable. We can't just live our lives that way. So what we want is a way to really be able to test the software. But we come to another point in time today. We live in a very different world than we did 15 years ago. Today, we live in the world of social media. The other day, I visited a website, I won't tell you which one it is, and it failed, unbelievably failed. It's a public-facing website. It's a travel website, I'll just say that. And that day I tweeted, I said, don't bother testing your software. If it does not work, your users will tweet about it. And this happens a lot. People put on Facebook, people put on social media. Isn't that embarrassing when people talk about your product and say how it sucks? So either we can take the time to test it, or we can take all these kinds of insults in the public media today. So I was wondering the other day, who's a software developer? And I think I figured out who a software developer is. A software developer is a profession where people get paid to write poor quality code and then get paid more to come clean it up afterwards. This is amazing. We are the smartest people on earth. Pay me now and pay me again tomorrow and the day after. This is job security, right? Unless a professionalism and ethics kick in, this will not change. Because we need to take pride in what we do. We have to take pride in saying, I wrote this code and I want to stand by it. I want to put my name on it. And I want to know that this actually works. I don't want to come back. You hire a plumber, and the plumber comes and creates a mess and says, I'll be back tomorrow to create a bigger mess. You're not going to be happy. But we are that people in organizations. We are delivering value, and we have to take the responsibility, ethics, professionalism to do that. We cannot be these kinds of software developers. We got to change the rules. So this is where automated testing becomes extremely important. But talking about automated testing, let me start out by saying, I love manual testing. I want to really emphasize it. Because people say, oh, we should really not do any testing manually. And the testers get all agitated. The testers get really angry. I'll tell you the first sign of trouble in any organization is where you have a development team and you have a testing team. This is a disaster in the making. If you want to make it worse, put an ocean between the two teams. That's even better. So they cannot even talk to each other directly, right? This becomes really hard. So I love manual testing, but I want to define what testing really is. To me, testing is an act of gaining insight. Does the code do what it's supposed to do? Is the program intuitive to use? Is the application workflow logical? Do we need to eliminate steps the user shouldn't be doing? I can't tell you how many times you go to organizations. I work with the team and I ask them, why are you doing this here? Because the requirement says it. Why is the requirement saying it? Because the business analyst wrote it. Why did the business analyst write it? It's what we need, just do it. No, I don't understand. Why are we doing this step? And 20 minutes later, one of the higher-ups will come and put a little cross and say, we don't need this step at all. Thanks for showing that to us. And they'll put a line around, and we eliminate chunk of work that we would have otherwise done. And this is a process where we're gaining insight. Does it make sense to be doing this? Hey, should we be really creating a different application maybe? And these are things we don't know how to automate. We rely on humans to give us the ability to do this. But let's understand the difference between the word testing and the word verification. What is verification? Verification is, it worked yesterday. Does it work today? Does it work after the change I made? That is verification. How many times do we verify software? Every minute it exists. Because we continuously modify code. Right? The only constant is change, Heraclitus said. The code keeps changing. We add features, we fix bugs, we make enhancements, we refactor code. Does it work? And I'm going to say we should never, ever manually verify software. No human should ever be subject to verifying if the code that worked yesterday is working today. It should be an insult to any human to ask to be done that, right? We have been subjecting testers to do stuff they shouldn't be doing in the first place. I'm not worried about testers losing their job. We never gave it to them. We've been asking testers to do what they shouldn't be doing in the first place. We deprived them of their jobs a long time ago. And we've been asking them to do something that we should be taking pride as developers and do, not them. So no human should be verifying software. It should be automated. So test manually, but verify automatically. And we have to automate these kinds of testing. It's extremely critical. If we cannot live the modern age, the digital age, by manually verifying software. I want to emphasize this. I do automation verification not because I have a lot of time. It is because I don't have a lot of time. I'm extremely busy. I cannot spend my time verifying manually. I can't be productive. I can't be successful. I can't produce results if I manually verify the software. That just won't happen, can't be. So in a sense, I travel around the world. I work with a lot of different companies. And this has been my observation. I've seen 3 kinds of companies so far out there when it comes to automated verification. The first kind of company are the largest we see. No automation. These companies are absolutely in denial. No, this is not for us. We will write code and we'll have more people hired and they will keep clicking away. And they'll click a button, enter things, and then they will say, yep, this worked. These companies cannot survive for too long. They are just facing a slow death. But unfortunately, this is the majority that we see out there. Then there is a small group of companies who have learned that automation is extremely important. And what have they done? They have said yes to automation. But unfortunately, here's the problem. These companies have said yes to automation. What did they do? They went off and hired people with really fancy titles. They said, here is Bob, our new automation engineer. And Bob comes over and says, hey folks, I'm your automation engineer, Bob. What does the programmer do? I'm pretty busy working. Hey Bob, welcome to our company. Don't bother us. I got bugs to fix. So Bob kind of sits there and says, I'm the automation engineer. My job is to automate. And so sits around for a few weeks. And then the boss comes to Bob and says, Bob, how's it going? Where's your automation? And Bob goes to the programmer. Programmers are absolutely defensive. Don't talk to me. And if you try to talk to them, they'll throw UML diagrams at you. You're like, oh, no, I can't handle that. So Bob comes up with a very clever idea. I've got this. So what does Bob do? Bob says, you programmers, sit in your corner. Don't worry about it. I am going to write test using Selenium. There's a name for this. It is called Pathway to Hell automation. A lot of companies are doing this. There are only 2 kinds of companies out there who do this. Those who have failed and those who are failing. I actually spoke to a company recently, and they said, oh, no, we got this covered. I said, no, this doesn't work. No, seriously. We have an entire team working in Vietnam for us, and they figured this out. I said, wow, that's amazing. Are you serious? Oh, I'll show you. So he takes me to his office. It's as if a ghost is sitting there and using the machine. You see this thing come up, it enters things, he clicks on the button, you can things change. Oh, it runs a little slow. I said, how much time does it take? 12 to 14 hours. Not too bad. But it works beautifully. Are you sure it works? Oh, absolutely. I said, can you do me a favor? I speak in conferences. The world needs this. If you will share your secrets, I want to go talk about this in every conference I can. I'll tell them there is hope, there is solution. He said, oh, I can help you with that. I said, okay, I'm already scheduled to be back here in 6 months. So when I come back the next time to your company, you and I one-on-one, we'll schedule 3 hours. I'll be your student. You teach me everything. I'll learn, and I'll go give the talks. Deal. So we shook hands. Well, 6 months goes by. I go there and said, hey, remember me? Oh, yeah. Well, you want to show me the demo that you said you will show? I want to learn about it. Oh, that thing, we haven't run it in 3 months. Like, why haven't you run in 3 months? Oh, the damn programmers, they changed the UI. Oh, never mind then. This is consistent, absolutely consistent. When I go to speak in conferences, people literally line up with towels, weeping. This is me. This is me. I do Selenium in my company, right? We hug each other, we console each other, and then we move on. We'll give it a special room if you want one, we can arrange for that. But the point really is, this doesn't work. It's brittle, it's expensive. I had a developer working in a European country. I'll be a little vague about it. His boss comes to me and says, my developer is having a lot of trouble, can you help? I said, let's do it. So I'm in Colorado, he is in Europe, we are on Skype, and he's explaining the problem. At the middle of the talk, I said, excuse me, hello, yep, don't do this. Go to the programmers, talk to them, go one level below the UI, automate your test there, don't do this. That was a conversation in January of last year. In July, I was physically in his office. And this tester comes to me and says, hey, Venkat, I'm so glad to see you. Remember me? We spoke in January. I said, oh, of course I remember. Well, you told me not to write the test in the UI level. I remember that too. I want you to know that I've been doing it for 6 months. I said, all right, how's it going? It doesn't work. I said, okay, so you should quit then. I told you already. No, I got a good news. I know you're coming. So I scheduled an entire day with you. I'm like, oh my gosh. And he was not kidding. On the schedule it says, entire day with him. So we start at 8 in the morning. We're sitting there, and I'm like, are you serious? Oh, absolutely. We're sitting with Selenium test, we're working. 3 hours later, I'm feeling like an idiot because nothing is working. I'm like, I don't understand. I mean, the application works. You go in there, you go to the list box, you select an item, everything around it changes. Beautifully, it works. Not in Selenium. And then I come to a realization, suddenly, I'm like, oh my gosh, I know what's going on. When you click, your human eyes don't see the speed. We humans don't notice anything which is less than 250 milliseconds in speed. This is so fast, you don't notice it, but Selenium is faster than that. So you got to slow it down. So I slow it down, and the test works. He jumps out of the seat. Oh my gosh, you made it work. Like, no, I didn't make it work. I showed you how it sucks even more. That is the problem, right? We are desiring to do the wrong things. And no matter how much we are educated, you come back in the day and saying, how do I do that wrong thing? Don't do it. So a better way is a few companies have learned to do it. This has a name. It's called the ice cream cone pattern. We live in a beautiful field. We'll do stupid things, but give beautiful names for it. This is called an ice cream cone pattern. Anyone here loves ice cream? Oh, yes, I love it. This is poisonous. Not that kind of ice cream you're thinking about. I love ice cream. I'll eat that all day. But this one is dangerous ice cream. This one, you do a lot of tests at the top level, very little at the bottom level. This is extremely unstable. This is an anti-pattern. We should not follow this. What we really want to do is what a few companies are doing. Right level of testing to the right measure. What we want to do is so-called test pyramid. And you want to start with more tests at the bottom, not 0 at the top, but fewer tests. This is written in Mike Cohn's book. A lot of other people have talked about it. My recommendation is at any given level, you write a test only if it cannot be possibly written at a layer below it. That's an absolute rule. You write a test at a level if and only if it cannot be possibly written at a layer below. You don't know how to do it, that's fine. I don't know how to do it, that's fine. We can put our heads together and try to figure out. But it's important to move it to a lower level where possible. Why is it so hard to do this? Well, when you hear people say, this code is hard to test, what they're really telling you is that the design of this code sucks. If a code is not designed for testability, it cannot be tested. Testability is an architectural concern. You cannot randomly walk to a piece of code and say, I got news for you. I'm going to test you today. And the code says, let me show you who I am, right? It's not going to work that way. You got to nurture the code. You got to prepare for it. And you got to build it for testing. You cannot just randomly go to a code and test it. So if we don't design the code for testability, it's no surprise it ends up not being testable. So we have to really work towards it. That's why this is an architectural concern. It's a design concern. So it is very hard to do this. But then again, I noticed something. I struggle with these things because I really want to learn. I want to understand why things don't work. And I would go to the smartest of developers. I'd go to them and say, here's a problem, go solve it. They would go away. They'll come back the next morning or later in the day and say, it's done. Show me a demo. Here you go. I would go to the exact same smart developers and I would tell them, here's a problem, go write test first and then write code after. And the same developers will struggle with it. And they're like, are you crazy? I can't do it. Why can't you write test and write code when you can write the code? And I was struggling with this, and I finally discovered why. And I was surprised I didn't realize this before. What is programming? Do please tell me if you program this way. You go to work, and you do this and say, I'm going to write code today. And then you type, and then you do this, and you walk away, and the code just works. Raise your hand if that's true. No. Javahar, come up here. We want to talk to you then. Is that the way you write code? Does it work that way?
Not always.
Not always.
Majority of the time.
Majority of the time. When you're drunk. Thank you. So it doesn't work that way, right? If it works, we got divine power in front of us, right? And we got to bow to it. But how do you normally make code work? I'm going to write this code. Damn, it doesn't work. It doesn't work. Scott, what's the API that I should call here? What's the second argument I should pass here? Not sure. Let me try this one again. And then you try something else. What happens? That doesn't work. Hey, let me look in Stack Overflow. Let me Google for it. And then finally, I think it works. Oh, wait, not yet. Does it happen to you? What is that called? Programming. Isn't that true? What is programming? Programming is a series of mini experiments where you discover so many things. Isn't that true? We have to understand what our profession is. Programming is a series of mini experiments. We constantly keep discovering things. Nobody sits down knowing everything. I don't. Scott, do you? Not today, not ever. Even when you write COBOL, absolutely not. But the point really is, it's a series of mini discoveries. Now we are going to that programmer and saying, I got a great idea for you. Don't discover. Don't experiment. Just write the test first, and then write the code later. And the programmer says, are you an idiot? That's not the way we write software. And once I understood that, I said, oh, that makes sense. So what should I do? Take very small steps. Divide and conquer. But the most important step we tend to miss is spike to learn. When you have a series of unknowns in front of you, don't write a test for it because you don't know what you're writing. Leave the project alone. Scoot over here to a completely new space, away from your project space, and do a very quick, dirty prototyping. Just do experimentation. Write a little code. Nothing to do with your project. No issue of code quality. You're not even in a full system. Just focus on that one problem you're solving. Write a little prototype, little experimentation, what we call as spiking. Go wild at it. Break it, make it work, put it back together. When you're done, have the discipline to leave it there. Never copy and paste that code. Now come back to your project. You have done your experiments. You have taken the time to learn. You have converted that unknown to some partial knowns. Now start writing test and writing code and writing test and writing code. Every time I do this, the code I develop using TDD is never structurally the same by design as the little spike I did. But the spike gave me the insight, the much needed insight that gives me the confidence that I have a path in front of me. The details of the path will emerge, but I have a path in front of me. And now I can start writing tests and writing code. And that piece is missing in a lot of people's effort. When we go to developers and tell them, write tests and write code, they feel absolutely lost. They feel absolutely confused, and they say, I don't understand. Are you really smart and I'm not? Because you are saying write tests and write code, but I don't even know what's in front of me. How can I write tests when I don't even know? Well, don't beat people down on them. Hey, go experiment, play with it, create a little prototype. And you see this happen in every field. Go to an artist. An artist never sits and creates an artwork. An artist creates prototypes after prototypes after prototypes. And the beauty is, the one place where prototyping is the most easy is in software. We should be doing that a lot more than anybody else. In fact, the world of 3D printing has gone this direction because it's easier to create prototypes at a lower cost. And we should be doing more of those as well. So is JavaScript ready for verification? And the answer is absolutely it is. We can write tests at various different levels. We can start writing the code and test at the bottom layers, and then we can go up. I exactly focused on this when I wrote the book, Test Driving JavaScript Applications. My goal was to show that we actually can spend the time writing automation testing every single level of this, and we can achieve it. So just to think about an example. I was recently teaching a course, so I said I'll use the example from it. So here's a little piece of Angular code, and I have automation testing written on this. I don't want to run the application to know I broke something. Remember, verification has to be automated, not manual. So I'm going to run the test right here. That's all I'm doing. I just started the test. And these are purely unit tests at this point, even though I do have integration test as well, but I'll just focus on the unit test. So here it's running the unit test. You can see all the tests are passing. You can see the green bar at the top. You don't have to know the details right now. But one of the things I want to do here is simply just to make a quick change. Maybe I fat-fingered into this. I want to know if I broke something. I don't want to bring up the app to know I broke something because that's way too slow. But I don't have to. I right away know I broke something because the automation testing is there. I view automation testing as the angels on my shoulder. They sit here on my shoulder, they watch me, and they whisper in my ears, they say, Venkat, don't check that code in, it sucks. That's an awesome feedback to have, because I would rather have my test tell me my code sucks than my customers and colleagues tell me my code sucks. So I can make the change, and I can make sure that the code is actually working for every single change I make very quickly. Similarly, I'm not sure I'm changing something and I removed that function. What is the impact of the change? Is that going to affect me? In this case, I'm just taking the changes and updating the form with it. But it tells me, no, you can't do it. That's not going to work. Even more important, a lot of times we take the pride in refactoring code. What is the point in refactoring code to figure out everything broke? Because the next time you say, I'm going to refactor the code, people will start laughing, isn't it? Oh, you're going to refactor again. Call in the testers, right? That's not going to work. So what do? We want to be able to get a good feedback. So notice, here is a code in the traditional imperative style of programming, as we know. So I'm going to take this code, and with all pride, I'm going to say, I'm going to make it functional. So how do I make this functional? Constant, and I'm going to say topping found is equal to, and I say this dot toppings dot, and I'll say, in this case, find. And what am I looking for? Given a topping, I want to say a topping's name is equal to the given topping, so in this case, the topping dot name. So once I find the topping, what's the next thing I want to really do here? Well, great, I found the topping. Awesome. And now I can simply say, the found topping, so topping found, dot description is equal to the given topping dot description. Well, refactoring is awesome, isn't it? Because you can show there are better ways to do it. But when you refactor the code, you want to know that things actually work. Because if they don't, there's no point in refactoring. So then you can realize, oh, maybe I didn't realize that there could be no element at all. Okay, so if topping was found, then I want to do this, not otherwise. And you have a really good feedback loop telling you that things are working now. So refactoring becomes much more safer and productive when we have these automated tests as well, and that is a huge benefit. So the point I'm really getting to is, if we want to achieve this, there are a few things we definitely need. The first thing we need is discipline. Unfortunately, we can't buy this. We have to grow this in our minds. So we have to develop the discipline. And I'm not a fan of saying, I would do wonderful things if only my boss lets me do it. That's a pathway to excuse. We are professionals. We have to take the responsibility for it. We need to take time. We need to have the skills. We develop the skills. And finally, we have to develop a culture for it. I'm going to say automated testing, automated verification is the software equivalent of exercising. Everyone here will agree exercising is good for health. But if I ask people to raise the hand, very few of us will raise, saying that we actually exercise. We always have excuses. As humans, we know to find short-term gains and lose sight of long-term benefits. I'm going to say it is 1820 all over again. What is 1820 though? Well, if you look at the medicine field, in 1820, people were dying after surgery. The death rate was enormous. People would go for surgery, within 2-3 weeks they'll be dead. Nobody understood why. A gentleman, Hungarian, a Semmelweis said, hey, we are causing the death. At that time, doctors used to walk around with blood on their coat. If a doctor was a great doctor, he had more blood, literally more blood on his coat. And he discovered we are carrying germs. He couldn't prove it at that time. Actually, he got killed at the age of 47. And then several years later, Joseph Lister and Louis Pasteur came along and said, hey, there's this thing called germ theory, which is true. And they started practicing the things that we do today. And the mortality rate really reduced a lot. I'm going to say we are currently in 1820s in the software field. We are practicing a beautiful craft. I honestly say this. I love programming for one good reason. And that is, we could be sitting anywhere. We could be sitting in a busy cafeteria, in a train, in a bus station, in an airplane, right here. But in our mind, we build the abstractions. In our mind, we build the concepts. This is like writing a poem. It's the art form. We are doing a combination of engineering and art together. I cannot imagine doing anything else in my life that would be more exciting. But we really need to come out of 1820. We got to come to 2017. We are practicing a beautiful, beautiful craft. Let's work together. Let's put our minds together. Let's turn this into a wonderful profession. I think we can do it. Thanks for listening.